class, Dr. Bans here. So let's take a look at this question. Find the Fourier transform of a triangular pulse. Okay, so this is a standard question. Okay, this is a standard signal. All right, so when we say standard signal, what we mean is that that question actually remains as it is. It cannot be changed in any form. Okay, so a triangular pulse is always just as it is a triangular pulse, and it always comes in this particular format that I'm going to draw. Normally the question will be given only in this format. Find the Fourier transform of triangular pulse. Okay, and it's a standard signal. Okay, so here when we say a pulse, it's a signal that comes once at a time. Okay, once at an instant. Okay, just like the pulse of your heart. Okay, so this is how it is going to be. So here I can have t. Okay, and then here this place is always what? 1 minus tau on what? 2. Here I am drawing my own diagram, and I am giving my own values to it. Okay, here 0, but this is a standard. It's a standard signal, so it's a standard question. So mostly in most textbooks you will find a similar pattern of what I am doing right now. Okay, that's why we call it a standard signal. Okay, so here is delta t of what? Tau, which is basically my what? X of what? T. Okay, that's my x of t. Okay, so this is a triangular pulse. This is a triangular pulse. Okay, signal. Okay, so here my x of what? T here is what? Equals to the triangular pulse. And this is how we represent the triangular pulse. T on what? Tau. Like this one. This is a triangular pulse. So now here, you know that if I am asked to find Fourier transform, Fourier transform is denoted by what? X of what? Omega. X of omega, the formula for x of omega is what? Minus what? Infinity to what? Infinity. Okay, x of what? T into what? E exponent minus j omega omega what? T. Okay, the what? The t. And this is for the interval minus what? Infinity to what? T, and then what? To what? Infinity. Like this. Okay, so this is for this interval. Okay, so now here the Fourier transform, instead of writing x of omega, I can also write what? Like this. Fourier what? Transform ft of what? Delta t on what? Tau. Okay, is equals to, okay, here you see that I actually have my limits. I actually have my limit, which is what? Minus tau on 2 and tau on 2. So instead of writing minus infinity and infinity, I can introduce those limits over there. Okay, so here I can say that I can actually say that here is what? Minus tau on what? 2, and here is what? Tau on 2. And instead of writing x of t, I can bring the triangular pulse representation, which is what? Triangle into what? T on what? Tau. Okay, and then here e minus j omega t what? Dt. Okay, and here my limit is from what? Minus tau on 2, minus tau on 2 less than what? T less than what? Tau on what? 2. Okay, so those will be my what? My limits. Okay, so now from there, one thing about a triangle, when the question is given in terms of triangle, is that we must determine the what? The equations of the lines. If it is a square, we don't have to determine the equations of the line. But whenever it's triangle, we have to determine the equations of what? Of the lines, because the lines are not straight. They are not perpendicular. Okay, they are not perpendicular. So they make a certain angle with the axis, and we have to determine the equation of the line. Okay, so here the points here is what? Minus tau on 2, 0, and the point here is what? 0, 1. So I'll determine the equation for this line, and I'll come to this line. This line, the point here is what? Tau on 2, 0, and the point here is what? 0, 1. So I will determine the equations of these two lines. Okay, so now To determine the equations of the first line, I'll use the what? The points. What are those points? Okay, so those points are going to be what? Minus tau on 2, 0. Okay, and then we're going to have what? We're going to have what? The next one here will be what? 0, what? 1. Okay, so those will be the points. So now, here, in that case, the slope is going to be what? The slope here, we're going to have our slope to be 1 minus what? 1 minus 0, okay, over what? 0 minus what? Tau on what? 2, okay. And then if we do this, we're going to get what? 2 on what? Tau, okay. Then we pick the next one, which is the second line. Wait, no, let us realize the equation for this line before, of this slope before, okay, of these points. So now the equation is going to be what? X of what? T minus what? Minus the y component, which is what? 0, okay, is equals to what? The slope, which is what? 2 on tau into what? Into t minus what? The y component, which is minus tau. So minus what? Tau on 2. Okay, and this one will give us the equation of the line, okay, which is going to be 1 plus 2t on what? On tau, okay. And this is going to be within what? The interval. Which interval? Okay, it's going to be within the interval minus tau on 2 less than what? T less than what? 0. It's going to be within what? The interval minus tau on 2 to what? 0. Okay, all right. Then we go to the next aspect, which is the next point. So which you got? Point what? We're going to have tau on what? 2, comma 0. And then we're going to have what? 0, comma what? 1. Okay, 0, comma 1. So with this one, what we're going to have is going to be slope. So what will be the slope here? So the slope here is going to be 1 minus what? 0. 1 minus 0 over what? 0 minus what? Tau on what? 2. Then our slope will be what? Minus 2 on what? Tau. Okay, our slope will be minus 2 on tau for the second one. Okay, then our equation is going to be what? X of what? T minus the y component of the first point, which is what? 0, which is equals to the slope minus 2 on what? Tau into what? T minus what? The s component of the first point, which is what? Tau on 2. So it's what? Minus tau on what? 2. Okay, so if we do this, then the equation of our line is going to be give us this. Okay, it's going to give us 1 minus 2. Okay, 1 minus 2t. Okay, on what? Tau. Okay, and this is going to be within the interval what? It's going to be within the interval 0 less than what? T less than what? Tau on what? 2. So these are our two equations, okay, which we are going to use, all right. So now here what we're going to have is that we're going to proceed with these two equations to find the limits, okay. We already know our limits, okay, but to find the exact Fourier transform that we're looking for. Okay, so here what we're going to have here is we're going to have x of what? You're finding Fourier transform. Okay, so I can say that x of what? Omega, which is Fourier transform. Okay, is from here is going to be equals to what? Minus tau on what? 2. Okay, to what? Tau on what? 2 into x of what? T. Okay, into e minus j omega t d what? dt. Okay, but here is the case whereby I know my x of t. So the first equation is going to be what? Is for minus tau on what? The first equation is for minus tau on 2 to what? To 0. And then it is what? What is that equation? That equation is what? We got 1 plus 2t on what? Tau into what? E exponent what? Minus j omega what? T d what? dt. Okay. So, and then the second equation, we got what? 0 to what? Tau on 2. Okay, and it's what? The equation was 1 minus 2t on what? Tau. Okay, into e exponent minus j omega t. Okay, d what? dt. Okay, so these are the equations that we got. Okay, so now what we're going to do again is that we're going to find the integrations for these equations. Okay, the integrations for these equations. But here you can see that I have to use integration by part. Okay, integration by part. All right, that is, I must determine the u and the v. So I'll take this one as u and I'll take this one as v in this case. And here I'll take this one as u and I'll take this one as what? V. Okay, and then I'll use integration by part. We have done integration by part in our previous lectures, which you can actually refer to them. Okay, so here integration by part is going to be u, okay, integral v minus, okay, minus here we're going to have differentiation of u and then a double integration of what? V. Okay, so basically this is a formula for the integration by part. Okay, so now if I should follow this formula, then I'm going to get for the first instance this one. Okay, this one I'm going to integrate this one. No, in the first instance, okay, I'm going to maintain it. I'll not integrate, I'll just maintain it. Okay, so if I'm maintaining it, it will be what? 1 plus 2t on what? On tau. Okay, then I'm going to differentiate this one. Okay, because here it's being differentiated. So if I differentiate that one, then I'm actually going to have e minus j omega what? T over what? Minus j omega. Okay, minus j omega. Okay, so now I'll come to this part. When I come to this part, I'm going to actually, so this minus, let me bring it here. This part, I'm going to actually differentiate this one. So I'll differentiate this one, okay? And then if I differentiate this one, what I'm going to get is that I'm going to actually have 2, okay? I'm just going to have 2 on tau, okay? I'm just going to have 2 on tau, all right? So let us see how it's going to be 2 on tau. But there is a minus here, so minus 2 on what? Tau, okay? Then what I'm going to do is that I will integrate this one 2 times. I'll integrate this one 2 times. If I integrate the first one, I'll get e exponent minus j omega t on minus j omega. Then I'll integrate another one. I'll get what? E exponent minus j omega t on j omega squared. Okay, so this is what I'll get. I'll get e exponent minus j, if I integrate it 2 times, minus j omega t over what? J omega what? Squared. Okay, so this is what I'm going to actually get. Okay, so now if I have this one, then I can close here like this and then put in my limit, which is 0 minus tau on what? 2. Now I can have plus, then I'll come to what? The next one. Okay, so the next one is this one. I'll maintain this guy. So I'll just maintain in the first instance according to here. Okay, according to this one, because u is being maintained. It's not being differentiated, it's not being integrated. It's being maintained as it is. Okay, so minus what? 2t on what? Tau. Okay, and then I'm going to differentiate this guy. So if I differentiate this guy, I have what? Minus j omega t over what? Minus j what? Omega. Okay, minus j omega. Okay, so now I'll go to the next part. Okay, what will be that particular next part? Okay, so now the next part will be this place. Okay, so this place I'm going to differentiate this guy. So I'll be differentiating this guy. So if I'm differentiating this guy, I'll get what? Minus 2t. If I differentiate this guy, if you differentiate 1, you get 0. If you differentiate this place, you get what? Minus 2 on tau. but there's already a minus here. So there's this minus here it is. There's already a minus here. And if you differentiate this guy, if you differentiate this guy, you get minus 2 on tau. So minus minus will be what? Positive. And I'll have what? 2 on tau. Okay, I'll have 2 on tau. Okay, then what I will do again is that I must differentiate this guy, integrate this guy 2 times, integrate this guy 2 times. If I integrate the first time, I'll get e exponent minus j omega t over what? Minus j omega. Then I'll integrate another time. I'll get e exponent minus j omega t on j omega squared. Okay, so that is what I will get. Okay, so I'll have e exponent minus j omega t over what? J omega what? Squared. Okay, then I can close it. And then I can have here to be what? 0. And here tau on what? 2. Alright. So basically this is what I'm going to get. Okay, so from here what I can do again is to introduce my limits. So we will introduce our limits from this particular point. Okay, so from this particular point we will just introduce what? Our limits. So always what we do is that we introduce the upper limits what? First. Okay, so x of what? Omega, which is what? Fourier transform, is going to be equals to, if I introduce the upper limit, okay, here for the first instance, which is what? 0. If I introduce that one, then I will get minus 1 over what? J omega. Okay, I'll get minus 1 over J omega. Then I put it into, let me show you. Okay, so if I put 0 here, this place will become 0. I'll be left with what? 1 here. And if I put 0 here, e exponent 0 is what? 1. Okay, so I'll be left with what? 1 times 1 will give me 1. So it will be 1 over what? Minus j omega. That's the same thing as what? Minus 1 over what? J omega. Okay, then I go to then I come to, sorry, I put in the first one. I'll be dealing with this place 0 and minus tau on 2. You introduce the upper limit first. So if you put 0 here, you get 1 plus 2 into what? 0 over tau. That place you get what? 1 here. And here, if you put 0 here, you get what? E exponent 0, which will be what? 1. So in that case, 1 times 1 is 1. And you have minus j omega here. So you have what? 1 minus 1 over what? J omega. Okay, so that is what you get here. And then you put in 0 into the second aspect also. Okay, you put 0 into this aspect also. Okay, so here e exponent 0 is 1. So in that case, you're going to have minus 2 on what? Tau j omega squared. Okay, j omega squared. Okay, that's what you're going to have. Okay, then you bring in this is for the upper limit. Then you bring in the lower limit. So the lower limit is what? Minus tau on 2. So if you put tau on 2 into the first part, if you put tau on 2 here, okay, if you put tau on 2 here, you get 0. So this part will become 0. Then you put tau on 2 here. If you put it here, this is what you will get. Okay, if you put it here, you will get what? 2 into e exponent what? J omega. Okay, tau on what? 2. Okay, over what? Tau over j, sorry, let me see, over tau. Okay, over tau into what? J omega what? Square. Okay, so that's what you're going to get there. Okay, now let's see, let's put in this one also. After that one, we have to deal with this place. Now tau on 2 into this one. If you put tau on 2 here, you get 0 here. It will become 0. Now you put tau on 2 into this one. If you put it into this one, this is what you will get. Okay, in that case, you're going to have 2 on what? Tau. Okay, here please, it is tau. 2 on tau. Okay, into e exponent what? Okay, minus j omega. Okay, minus j omega tau on 2, okay, over what? Over j omega what? Squared. Okay, so that is what you're going to get there. All right. Then you put in what? 0. This 0, you put it here, and then you put it also here. Okay. So if you do that, if you put in the 0, this is what you're going to. This is what you're going to have. Okay. You're going to have plus 1 over j omega. Okay, and then you're going to have minus 2 on tau j omega squared. Okay, so this is what you're going to have. Okay, so this is what you're going to have at the end of the day. So now you can see that this guy and this guy, they are opposite. So they will cancel each other. They will cancel each other. So this guy will cancel this guy. They are opposite. They will cancel each other. Okay, so now the Fourier transform. Okay, instead of writing x of omega, I can also write Fourier transform for what? Triangular pulse. What is t on what? T on tau. Okay, and it's the same thing as what? X of what? Omega. Okay, so the Fourier transform now is going to be, I'm now going to have this one, okay, and then I'm also going to have this one, okay, I'm going to have this one, and I'm going to have this one. Okay, so those are the ones I'm going to deal with. Okay, so now here I can actually bring 2 on what? Tau out. Okay, and then j omega squared can join them. Okay, if I bring that one out, I'll be having this one and then this one. Okay, so in that case I'll have e exponent what? J omega what? Tau on what? 2. Tau on 2 plus this place. Okay, so plus this place, which is what? E exponent minus j omega. Okay, into what? Tau on what? 2. Okay, so that's what I'll get. Okay, then I can close it. All right, then this place, this one, okay, and this one. Okay, so this one and this one, that one I'll get what? Minus 4 on. I'll get minus 4 on what? Tau into what? J omega what? Squared. Okay, j omega what? Squared. Okay, so that is what I'll get. Okay, so now what if I have this one? The first thing to deal with is this place. So this place I have to use what? Cos and sine. Okay, so basically that place is going to be equals to this one. So let me say x omega is equals to 2 on what? Tau into what? J omega squared. Okay, into what? Into cos omega tau on what? 2. Okay, plus j sine omega tau on 2. Okay, plus cos. Okay, plus cos what? Omega tau on 2 minus j sine, okay, omega tau on what? 2. Okay, minus this one, okay, which is what? 4 on what? Tau, okay, j what? Omega what? Squared. Okay, so this is what I'll have. So now I can cancel this one and this one because they are opposite, and I'll be left with what? This one. Okay, I'll be left with this one. So now here you see that this one is 2. They are 2. They are 2. So it will be what? 2. So I'll bring that the 2 what? Outside here. Okay, so I'll have x omega is equals to, so now this one they are 2. So if I bring that 2 outside here, I'll get what? 4 over what? Tau into what? J omega what? Squared into what? Cos tau on what? 2. Okay, minus 4 over what? Tau into what? J omega what? Squared. Okay, so this is what I'm going to have. This is what I'm going to have. So now if you have this one, then what happens is that here is what? Omega. Okay, so it's what? Omega tau on what? 2. But we know that whenever you have this one, okay, you see that this one and this one basically they are just opposite. Okay, and but this one is multiplying, so I cannot cancel, but I can factorize them. Okay, I can factorize them. So if I factorize them, then basically what I'm going to get is I'll get 4 tau into what? J omega squared. j omega squared into what? Cos what? Omega tau on what? 2 minus what? 1. So this is what I can have. Okay, so this is what I can have. Okay, so now if I have this one, then okay, this the is equals to this. Okay, so now this is my Fourier transform. But if you have this expression, okay, and if you have this expression, then it can actually be simplified further, okay, in terms of trig, because we know that cos theta is equals to 1 minus 2, okay, sine squared, okay, theta on what? On 2. Okay, so that means that I can put this one here. Okay, then it will become what? 4. Then it will become what? 4 on what? Tau j omega squared. Okay, is going to what? 1 minus 2 sine what? Squared. Okay, into theta over 4. Theta over 4 here is what? Omega tau, okay, over what? Into what? So it's going to be what? 2 sine squared theta on 2. Theta on 2. But there is already 2 here. There's already 2 here. So if I join it with these 2, then it will become what? 4. Okay, then it will become 4. Then I can bring this minus 1 here. So minus what? 1. Okay, so this becomes my equation. Okay, so this place is what? Tau. So this becomes my equation. Alright, so now basically what I can do again is that this one and this one, they are opposite. So I can cancel them. This one and this one, they are opposite. So I can cancel them. So if I do that, then my Fourier transform now is going to be 4 on tau into what? J omega what? Squared into what? 2 sine squared omega tau on what? 4. Okay, so now what I can do is that my Fourier transform now is going to be, I can multiply this 2 and this 4. So if I multiply them, I'll get 8. I'll get 8 on what? Tau j omega what? Squared into what? Into sine squared omega tau on what? 4. Okay, so this is what I get. Okay, so now what I can do again is that I can reproduce this one in terms of what? Sinc. Okay, in terms of sinc. Okay, because you know that sinc theta or sinc what? Sinc theta or sinc what? X is equals to what? Sine theta over what? Theta, or what? Sine what? X over what? X. Okay. So in terms of what? Sinc, I can what? Represent it. Okay. So now what we can do again is that we can just represent it in terms of what? In terms of sinc. Okay. In terms of sinc. Okay. There is one thing that I have to tell you. Okay, so please, there's something I have to make you aware of. All right. When we were coming, okay, you see that here, this place was minus. Okay, you see that this place I had a minus here. Okay, so that minus should actually come here. Okay, and that minus should actually what? Come here. Okay, so now you see that whenever you have j squared, what is j squared? J squared is minus 1. Okay, j squared is minus 1. Okay, so now that minus 1 will cancel this one. Okay, that minus 1 will cancel this one, so that this place will actually be equals to 8 over tau omega what? Squared. Okay, omega squared into what? Into sine what? Sine squared. Okay, into omega tau on what? 4. Okay, so this is how it will become. Okay, so this is how it will become. Okay, before we actually even move on to the sinc. Okay, So now that's how it will become. Okay, so let's move on to our sinc value. But here, one thing you have to know is that our sinc will not be normal sinc. It will have to be sinc squared. Why am I saying it has to be sinc squared? Because we have what? Sine squared over here. Okay, because we have sine squared here, so we will also have what? Sinc squared. Okay, so we're going to have sinc squared. So let's see how we can actually be able to do this sinc squared. So now, because I have sine squared here, what I'm actually going to have is that I'm going to have sine, I'm going to have, okay, sine theta, okay, squared what? Theta, okay, which is equals to what? Sinc squared what? Theta, okay, sinc squared what? Theta, okay. So that is what I'm actually what going to have over here. Okay, so now here, if I have this one, then what I'm going to get is that in terms of sinc, then I'm going to have my x omega here, x of omega here is going to be sine omega on 4, okay, omega on 4, okay, over omega on what? On 4, because it has to be what? Sine theta over what? Theta, okay. So all of this one, okay, all of this one being what? Squared. All of this one being squared, okay. So now, one thing I have to do is that whenever you are writing this one, you must make sure that it does not change the original equation, okay. It does not change the original equation. So this omega tau is what I have here, omega tau on 4. This omega tau on 4 is what I have here, omega tau on 4. Now, you see that I have brought what? Another omega tau on 4 here. Where did I get this omega tau on 4? Okay, so now here, this omega, what you have to know is that this omega I have here is actually what? Omega squared, because there's a square here. So this omega squared, he can come here, okay? And then this tau too, he can come here, okay? But this tau here is not squared, okay? But the tau here is squared because there's a square here. And then this 8, okay, he can come here. But the 8, when he comes here, he'll be left with what? 2, okay, 2. So this tau, I have 1 tau here, but I have 2 taus here. That means that I must actually multiply here by what? Tau. And this one here, okay? You see that this 8 is top here. Now he has come down here. So, but you still be left with what? 2. That 2 must actually what? Come down, because he's what? This one is what? Down here. Okay? So this one will give me what? My sinc. Okay? My sinc. So now this one is equals to what? 2 on what? Tau. Sinc what? Sinc squared. Sinc squared omega what? Tau on what? 4. So that is what this would give me. Okay? So now if you have this one, if you know this one, the rest is very easy. You just plot your what? Your sinc diagram. Okay? You just plot your sinc diagram. So let's just finish this question by plotting our diagram. So now x of what? Omega is actually equals to what? Is actually equals to what? Tau on what? 2. Sinc what? Sinc squared. Omega tau on what? 4. Okay, so that is what? Our omega. Now to plot the diagram, okay, you will just do it this way. Okay, so here it is going to be like this. Okay, now we are in the frequency, we are in the Fourier transform domain. Fourier transform domain is what? Frequency domain. So our axis here will become what? Omega. Okay, and this one becomes what? X of what? Omega. Okay, x of omega, which is actually equals to what? Omega on what? Omega on 2. A tau on 2. Sinc what? Squared. Okay, omega tau on what? 4. Okay, so here for the sinc square, it will lie exactly on the axis. Okay, sinc square will lie on the what? Axis. Okay, So here, but it will be a decaying signal. Okay, that means that with respect to time, it will be oscillating. That means that it will be what? Dying off. It will be decaying. Okay. Okay, something like this. Okay, so this one here. Okay, so its strongest part, the strongest part of the sync is the 0. Okay, and sync 0 is always what? 1. Okay. Okay, so something of this sort. Okay, something of this sort. So here is what? Sync 0. Okay, and then how do we determine our values? Okay, so we know that sync 0 is where it has the highest what? Amplitude. Okay, so now here the highest amplitude is at the 0 part. Okay, we know that omega tau on what? 4. Okay, must be equals to what? N pi. Okay, must be equals to n pi. Okay, so now here, then that means that what will be omega? Then omega will be equals to what? 4 n what? Pi on what? Tau. Okay, 4 n pi on tau. That means that here is what? 4 n what? Pi on what? On tau. Okay, and then here is what? Because here, sorry, here is 4 pi, because here is n is what? 1. Okay, so sorry, here is what? 4 pi. 4 pi on 4 pi on what? Tau. Okay, so 4 pi on tau, please. Here is 4 pi on what? Tau. Here is what? 2. So 8 pi on what? Tau. Okay, 8 pi on what? Tau. Here is what? 3. Okay, so what? 12 pi on what? Tau. Okay, 12 pi on what? Tau. Okay, here is what? 16 pi on what? 16 pi on what? On tau. Okay, here is what? Minus 4 pi on what? Tau. Minus what? 8 pi on what? Tau. Minus 12 pi on what? Tau. Minus what? 16 pi on what? Tau. And here, what will be the value here? Okay, we know that sync 0, okay, is equals to 1. And this place is what? Sync 0. So that means that this place will be what? 1. If this place is 1, then this place will be what? Tau on what? 2. Okay, so that means that here is going to be what? Tau on what? 2. Okay, so this will be the solution that we require for this particular question, and this will bring us to the end of this particular question. Okay, so let me just, so now what we can say is that the Fourier transform, okay, for this one, the Fourier transform for triangular pulse, okay, on what? Tau, is going to be equals to sync what? Sync square what? Pulse. Okay, sync square pulse. And what is that sync square pulse? That sync square pulse is what? Tau on what? 2. Okay, sync what? Squared omega or tau on what? 4. Okay, omega tau on 4. And then now let me show you a short way to be able to also deduce your answer. If it's objective answer, you can use the short form. But if it's a theory answer, you're supposed to what? Show all the working as I have done here. Okay, so if it's like objectives, you can just say that here is what? 0 minus tau on what? 2. Tau on what? 2. Okay, and then here is supposed to be what? 1. Okay, so here the Fourier transform here is going to be, okay, always you have what? Your sync what? If it's a triangle, you know that's your sync squared first. Okay, and then after your sync squared, you're going to have your what? It's your area first. Your area must come here. So what is the area of this what? Triangle. Okay, you know that the area triangle is what? Half base times what? Height. Okay, half base times height. So what is half of the base? Okay, so the half of the base here. Okay, so half base, that is what? Tau on what? 2. That is half base. Okay, times height. What is the height here? It's 1. Okay, times 1. Okay, okay, so basically that's what you're going to have here. Okay, so that one should give us what? Tau on what? 2. That one should give us tau on 2. Okay, so that means that here is going to be tau on what? 2. So that's the area, because triangle is what? Half base times what? Height. Our height is 1, and our base is what? Tau. Half of this one. From here to here is tau. So half of this one is what? Tau on what? 2. Okay, so half base times height. Okay, so that is the area. Okay, then we come to what? To the angle aspect. That one you write what? Omega first. Okay, omega first. Okay, then when you have written omega, then it is going to be this one is going to be how do I even call it? What you're going to actually have here is that you're going to have half of the base. Okay, so what is half of this base? Half of this base is what? Tau on 2. So into what? Tau on what? Tau on 2. Okay, divided by 2. Divided by what? 2. Okay, so in that case, it is going to be what? In that case, you're going to actually have let me draw it in so you see. Okay, so you're going to actually have here is what? 1. Okay, so minus tau on what? 2. 0. Tau on what? 2. Okay, so the Fourier transform is going to be what? Tau on what? 2. Okay, sin what? Squared. Okay, so here omega, you write omega first, and then half of the base is what? Tau on 2 divided by what? 2. So that means that you're going to have omega or tau on what? 4. Okay, so that is how you can what? Deduce this one. Thank you so much, and see you in the next class.